Hello, can you hear me? Hello, can you hear me now?
Yeah,
Okay. You had some exam yesterday.
yeah, I had exam, UC exam.
Okay. It was physics, chemistry, maths only, right?
No, this was a design exam.
So what was there in that?
It's like there is a lot of logical maths, yeah, other than no physics in chem.
Just maths.
Yeah,
Okay. How was it?
it was good.
Okay. Uh, and your Allen tests are going on, right? Weekly.
Yeah.
How was your last test score?
Last test was
Friday,
the
right?
same one that I learned, some 190, I think I got.
Okay. Okay, so what we'll do, we'll alternate physics and maths. So today we'll do maths, tomorrow we'll do physics, like that, right?
Okay.
Because there are some topics in physics, I think your revision is missing, right?
Yeah,
So we'll do that.
yeah.
We'll continue with conic sections. Parabola we had almost done. Ellipse and hyperbola we'll discuss. Uh, so some questions which are JEE mains questions. So this is the first one. Which of the following points lies on the locus of the foot of the perpendicular drawn upon any tangent to the ellipse x squared by 4 plus y squared by 2 is equal to 1 from any of its foci. And options are -2 comma root 3, b -1 comma root 2, c -1 comma root 3, d 1 comma 2. Which of the following points lies on the locus of the foot of the perpendicular drawn upon any tangent to the ellipse from
Mm-hmm.
any of its foci? So this locus you will need to know.
Yeah.
This is an arbitrary tangent at some point. The point can be a cos theta, b sin theta.
Yeah.
On this tangent, you can drop a perpendicular. Right now, it looks already perpendicular at that point, so I will make it a little different.
Yeah. Need not be the point of intersection.
Yeah, obviously. Let's put it here, right? The
Right.
perpendicular will be somewhere here, right? This
Yeah.
is the point a cos theta, b sin theta, where the tangent is drawn.
Right.
Locus of this we need, right?
Hmm. Yeah.
Okay, so try to get this h comma k.
Like tangent equation, we can put as the mx plus root of.
If you are taking this point, parametric point, then you can write it x cos theta by a plus y sin theta by b, right?
Yeah, yeah.
Otherwise, you can do tangent equation as mx plus root of and all, but there will be m there. And
Right.
is that easier or is that harder? I don't know. So you can decide. Like here, finding a foot of perpendicular on this from AE comma 0 seems straightforward, right?
Hmm. Right. Right.
It will come in terms of cos theta and all, theta, right?
Yeah. So like I was thinking we can find the equation of tangent and then like perpendicular will be slope. You can put as -1 by m.
That's fine.
And
That
then
will
it
give
has
you line
vast.
equation, but then you'll have to solve it. No?
Yeah.
Like you will get a line equation, you'll have to solve it. Solving will be similar effort, right?
Right. Right.
To find h comma k.
Yeah. Yeah.
So uh, either of the ways it's fine, but this is also a way, that is also a way. In that case, you'll have to solve the two lines, right?
Hmm.
Here, what
Yeah.
I'm saying is, I will use the foot of the perpendicular thing, right? The x minus x1 by a, that one, right?
Yeah.
Like foot of the perpendicular to the line ax plus by plus c is equal to 0 from the point x1 comma y1, right? Is x
Hmm.
minus x1 by a is equal to y minus y1 by
Hmm.
b is equal to minus ax1 plus by1 plus c by a square plus b square, right? Correct.
Yeah.
Here my line is this. So a is cos theta by a, b is sin theta by b, c is -1, and x1, y1 is this and this, right?
Yeah. Hmm.
So a little bit of solving has to be done. There is nothing you can do. You have to do it.
Hmm. Hmm.
X will be a times this to x1 minus a times this, and x1 is ae minus a times a is cos theta by a times this by ax1. In this line you put ae comma 0, so e cos theta minus 1 by a square plus b square by cos square theta by a square plus sin square theta by b square,
Please.
right?
Yeah. Yeah.
This is what should come, and y should be y1, which is 0, minus b is sin theta by b, into
Hmm.
ax1 plus by1 plus c is same thing, e cos theta minus 1, and this is same thing, right?
Yeah.
Correct.
Correct.
This is
Correct.
what is coming. Now, what we need, okay, let's call this whole thing as some t, right? Because that is same both places, right?
Yeah.
And we can say that x minus ae multiplied by a by t minus is cos theta, right? Right?
Hmm. Yeah.
And minus by by sine theta and by t is equal to sine theta, right?
Correct.
Okay, this doesn't work because there is still theta in the t. No, I thought it will eliminate it immediately, but it won't do this.
Hmm.
T has the theta part, right?
Yeah.
So maybe we have to simplify a little bit. Uh, we get cos square theta by a square plus sin square. Okay, x is coming out to be uh, a square e cos square theta by a square plus sin square theta by b square minus cos square theta e plus cos theta divided by a into cos square theta by a square plus sin square theta by b square. This this cancel e cos square plus e cos square cancels. You get on top e sin square theta by b square
Uh-huh.
plus cos theta
Minus cos theta. Yeah.
plus cos theta. You
Hmm.
get
Hmm.
e sin square theta by b square plus cos theta. Wait, not e. You get a square e into this, right? A square e, right? A square e by b square sin square theta by this. So, okay, this doesn't seem very nice. Like a square e sin square theta plus b square cos theta. Here we have we cancel one a and one a. We get this a e sin square theta by b square plus cos theta by a, and here we get cos square theta by a square plus sin square theta by b square. And doesn't come out nicely. Now I'm thinking maybe the mx one is better. Okay, the other way to solve it.
Mm-hmm. When we took y here, we took like y minus y1, right?
Uh,
So we had to multiply by b also, right? Y minus y1 by b.
we did that. No, y minus y1
Oh.
by b. I multiplied is equal to minus. So b was sin theta by b. No,
Oh yeah, yeah, okay.
we have done it correctly. It's just that it is too complicated. This expression. It
Mhm.
might take some lot of simplification to get it, but if we do the other thing, what you were saying, y is equal to mx plus root over a square m square plus b square, right?
Yeah, root over
Is the tangent.
4m plus 2. Yeah.
So, okay, we can just put the value mx plus root over 4m square plus 2, right?
Yeah.
And AE, E and all we can find for this, right?
Correct. E is, yeah, 1.
E is 1 by root 2, right?
Yeah.
AE is 2A into E. So root 2 comma 0
Root 2. Yeah, root
is the
2.
point, right?
Yeah.
And slope of the line from here will be minus 1 by n. Okay, this is much easier actually, right?
Yeah.
So y minus 0 is equal to minus 1 by m x minus root 2, right?
Yeah.
So we are getting y is coming out to be minus 1 by m x minus root 2 is equal to mx plus root over 4m square plus 2, right? Uh,
Root over 4.
m square x. Okay, you'll get minus x by m plus root 2 by m minus root over 4m square plus 2 is equal to, you get mx plus x by m, right? Right,
Mx plus.
right. Huh? X is coming.
Yeah.
X and y will both come. They will have m and all, right?
Yeah. Yeah.
We'll simplify this and we'll say x is equal to uh, 1 by m plus 1 by m root 2 by m minus root over 4m square plus 2. If we take root 2 common outside, root 2 can be taken common outside. It will be 1 by m minus root over 2m square plus 1. That is your x. If we know our x, y will again be slightly annoying. Still, it will be a little difficult to solve, right?
Yeah. Like,
Slightly difficult to solve still. Uh,
instead of that, what if we say like we found two line equations, right? One for the perpendicular and one for the tangent. Like we can say both of them will pass through h comma k, right?
that's true. You can h comma k and then you can put h comma k there. But the lines are not identical. You cannot compare and all, right? You still have
Yeah.
to solve. Uh, Locus of the feet of the perpendicular drawn from focus to any tangent of the ellipse is the so okay, let's think about this geometrically. Let's say we have an ellipse. Let's say AE is somewhere here. This is minus AE comma 0. This is the auxiliary circle. This circle is x square plus y square is equal to a square. This ellipse is x square by a square plus y square by b square is equal to 1. Right? Uh, equal to- there is a tangent somewhere here. Right?
Right.
And perpendicular from here. Apparently, it lies on the auxiliary circle. That is what the answer says, that the locus is the auxiliary circle. So can we prove it in some other way is what I'm thinking. Can we prove that the point of intersection of the tangent and this perpendicular to the tangent lies on the auxiliary circle? Suppose this point is a cos theta b sine theta. Tangent equation. Let's at least confirm this, okay? So let's say tangent equation is x cos theta by a plus y sine theta by b, right? Correct?
Correct.
At the point a cos theta b sine theta. right? Now, where does this line cut the circle this, right? Correct. Where does this
Right.
line cut the circle? So it will cut the circle at 2 points, but solving it, it will again probably be annoying. Can we prove it in some other way? Hmm, this this angle is theta basically, right?
Right.
This angle is theta, right? This point is a cos theta, a sin theta.
Yeah.
Right? Uh, hmm. One easy tangent would have been at the topmost point, right?
Right.
That tangent would have been y is equal to b, right?
Yeah.
Correct.
Yeah. Yeah.
Where does that cut this? That is easy to find at least, right?
Right.
X will be root over a square minus b square, right?
Root of, yeah.
This
A
point
square
is root
minus.
over a square minus b square comma b, right?
Yeah.
Let's find, oh, okay. Notice that this is a common 1 minus b square by a square, right?
Yeah.
Right, see?
Yeah. Yeah. A comma B.
So at this point, the tangent is cutting it such a way that it is making 90-degree with this is vertical line, right?
Yeah.
At at this point, tangent and this point are coincident. It is tangent to both the circles, both the circle and the ellipse, right?
Right. Hmm.
So again, this is 90-degree. The line from focus to the tangent.
Tangent. Yeah.
I mean, two cases it's coming. It's just that it's hard to solve the other cases, right? You understand what is happening?
Yeah. Correct.
Like it's hard to solve, like it will be annoying to solve and prove that this is 90-degree, right? Uh,
Hmm. Yeah.
wait 1 second. Can we? No, still. I mean, we'll have to solve this with the circle, right?
Yeah.
Uh, but apparently this is true. And one case it is obvious it is coming, right? This case. This is not a trivial case like this one, right?
Yeah. Hmm.
We are drawing a tangent at the topmost point, and that is intersecting it at this point, which is A comma B, which is when you join it to the focus, it's perpendicular here, 90-degree, right?
Hmm. Yeah.
So for now, you should just remember what is the locus to remember? Locus of foot of the perpendicular from focus, any focus of the ellipse to the to any tangent,
Hmm.
right? Is the auxiliary circle.
Right.
Okay. So if you know this, then immediately you know that the locus will be, locus of foot of a perpendicular would be this, right?
Yeah.
In this case, the foot auxiliary circle would be x square plus y square is equal to 4, right?
4, yeah.
And then you can see that -1 comma √3 satisfies. Like, unless you know this, there is no chance of doing this doing this question in the exam, right?
Hmm.
Locus of the foot
Right.
of perpendicular from the focus of any focus of the ellipse to any tangent is the auxiliary circle. So basically it means that the tangent to the ellipse cuts the auxiliary circle somewhere. And when you join that point to the focus, it will always be perpendicular,
Yeah.
right? And even to any focus, like if it cuts here, like it can be joined here to this focus, I think. That doesn't make sense. It will cut here, no, not here. It will cut here, right? Right.
Yeah.
The figure is obviously wrong, but maybe this angle will not be 90, but one side at least it will be 90, right?
Correct. One side.
You will have to draw a few figures and see what is happening. But this was
Hmm.
asked in JEE Mains 2020. So this locus definitely you need to know, because in the exam it is not possible to do this in time.
Right.
Correct?
Yeah. Yeah.
So just make a note of this somehow, somewhere. Uh,
Yeah.
you have written it down.
Yeah. Okay.
Okay. Then if E1 and E2 be the eccentricities of x square by 18 plus y square by 4 is equal to 1, and x square by 9 minus y square by 4 is equal to 1, and E1, E2, comma E2 is a point on the ellipse 15x square plus 3y square is equal to k. Find k. This is straightforward only.
Yeah. So E1 is √7/3 and E2 is √13/3.
Hmm. So
And
even
that
comma
you need to.
E2 is a point on it. So just put that right.
Yeah. B.
K should come out to be 16.
Yeah. 1 second. Yeah.
All
16.
right. This is fairly easy. Then next one is length of the minor axis along y axis of an ellipse in the standard form is 4 by root 3 if this ellipse touches the line x plus 6 pi is equal to 8, then E is equal to what? What is the eccentricity?
So like B is 2 by root 3.
Hmm.
And we can put, like, we can use tangent equation, no?
Hmm.
Because this line should be tangent to that.
Hmm. You can use the condition for line to be tangent to an ellipse.
Yeah, so like mx plus
Hmm.
root of a square m square plus b square.
Hmm.
And that should be the same as y is equal to minus x by 6 plus 4 by 3, something like that.
Hmm. M is minus 1 by 6.
And root of a square m square plus b square is 4 by 3.
Correct?
Yeah.
So 4 by 3 is C. So 16 by 9 should be equal to a square is not known. M square is 1 by 36 plus b square is 4 by 3, right?
16 by 3. 4 by b is 4 by root 3. Yeah. So,
Right. So 2
b
by
is
root 3 whole square, right?
yeah.
So you will get 64 minus 48 is equal to a square.
Right. A square is 16. Yeah.
So e square is 1 minus b square by a square.
3 into 16.
4 by 3 into 16.
Root.
11 by 12, right?
Yeah.
E is root 11 by 2 root 3.
Yeah. Yeah.
That is your answer. This was also fairly straightforward only. Then the next one is, these are all mains questions. So next one is line y is equal to mx and the ellipse 2x square plus y square is equal to 1 intersect at P in the first quadrant if the normal to this ellipse at P meets the coordinate axis at -1 by 3 root 2 comma 0 and 0 comma beta, then beta is what? So here it will be convenient if you remember equation of normal at x1, y1, right? At an arbitrary point, equation of normal x1, y1 is a square x by x1 minus
Mm.
b square y by y1 is equal to a square minus b square.
Okay.
Generally, this is not a form that I ask people to remember, but if you know it, it is faster. Generally, you get the normal equation in y is equal to mx. No, you get it by just finding tangent equation and finding the slope and stuff, right? By doing y minus y1 is equal to m into x minus x1. Correct?
Yeah.
Y minus y1 is equal to m into x minus x1, and slope of suppose ellipse is x square by a square plus y square by b square. Tangent equation is x1 by a square plus y1 by b square is equal to 1. So slope of tangent is minus x1 by a square and y1 by b square. So slope of normal is a square y1 by b square x1. Right?
Yeah.
So you will get y minus y1 is equal to a square y1 by b square x1, x minus x1. So you can do y minus y1 by a square y1 is equal to x minus x1 by b square x1.
X1. Yeah.
Right? So this becomes actually b square. I should multiply here b square y minus b square y1, right? By y1 is equal
Uh-huh.
to a square x minus a square x1 by x1, right?
Right.
And this comes in the form, see, a square x by x1 minus b square y by y1 is equal to, this becomes minus a square goes this side, a square minus b square, right?
Yeah. Yeah.
So it can be derived, but it would be nice if you know this. So in this problem, it will be useful. Like if you directly write this, like a square and b square in this ellipse are what?
1 by 2 and 1.
So this becomes x by 2x1 minus y by y1 is equal to minus half, right?
Right.
This is the normal at x1, y1, right? Now, this normal and x1, y1 is supposed to be first quadrant,
Yeah.
right? This normal intersects at here and here, x and y axis. So these points lie on this normal,
Yeah.
right?
Correct.
So you can find x1, y1 from there.
Yeah.
Minus 1 by 3 root 2 into 2x1 minus 0 is equal to minus 1 by 2.
X1 is 1 by 3 root 2.
And 0 comma beta. Okay, if I get x1, I can get y1 from here, right?
Yeah.
So 2 into 1 by 9 into 2
Into 2.
plus y square is 1. So y square is 8 by 9. So y is equal
Yeah.
to 2 root 2 by 3, right? y1.
Yeah.
So x1, y1 is 1 by 3 root 2 comma 2 root 2 by 3. And 0 comma beta also lies on it. So 0 if you put minus y by minus beta by y1 is equal to minus half. So beta
Yeah.
is equal to
1.
y1 by 2, right?
Yeah. So beta is 2 root 2 by 3.
Root 2 by 3, correct?
Yeah.
So equation of normal passes through 2 points and also x1, y1 lies on the ellipse, right?
Yeah.
These three things, if you use, you will get it,
Right.
correct? From equation
Yeah.
of normal and passing through this point, we get x1. And once we get x1, we can get y1. Once we have both, beta comes in terms of y1, right?
Right.
Okay. Then question is, if the distance between the foci of an ellipse is 6 and the distance between its directrices is 12, find the length of the latest rectangle. Pretty straightforward, just find the answer.
Intersectum is 3 root 2, right?
That is correct for first one. Second one.
Would be 2√7.
This is 2√7. This is 3√2. Right? These were easy, right?
Yeah.
Okay. This one is advanced 2021. Let E be ellipse x square by 16 plus y square by 9 is equal to 1. For any three distinct points P, Q, Q dash on E, let M, P, comma Q be the midpoint of the line segment PQ, and M, P, comma Q dash is midpoint of segment PQ dash. Then the maximum possible value of the distance between MPQ and MPQ dash as PQQ dash vary on the ellipse E is what? You understand?
Yeah. Mhm.
Very nice question. Like, if you get the idea, there is not much to calculate.
So like you have to take any 3 points and then
Hmm?
like if you just take any 3 points P, Q and Q dash on the
Take any 3 points. Take any 3 points and see what is being asked by drawing the figure.
Mm-hmm.
So let's say P is somewhere here, Q is
Yeah.
somewhere here, Q dash is somewhere here. Midpoint of MPQ, right? So if I join this midpoint, right? And
Correct.
midpoint of PQ dash. If I join this somewhere midpoint, we have to find such a thing that maximum possible value of this distance, right? Correct.
Yeah.
Maximum value of this distance. So it is natural to do what here? Join this, right?
Yeah.
And if these are midpoints, this is midpoint theorem.
Like,
You've heard of midpoint theorem, no?
yeah.
Line joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it.
Half. Yeah.
So this distance is always going to be half of QQ dash, right?
QQ dash. Yeah.
So if I want to make this as big as possible, I want to make QQ dash as big as possible, right?
Yeah.
What is the biggest QQ dash you could have selected?
Will be like length of major axis.
Right?
Yeah.
Q could have been here, Q dash could have been here, and P can be anywhere after that,
Yeah.
right?
Right.
Half of that will always be 4, right?
Yeah.
That is the answer.
Okay.
This is a nice question. It's actually not a coordinate geometry question, it's just geometry.
Yeah.
If you just draw the figure and join the triangle, it becomes midpoint theorem, obviously. Right?
Yeah. Yeah.
So this was advanced 2021. Now, then let's look at this one. This is mains 2021. Let E be an ellipse whose axes are parallel to the coordinate axis, having its center at 3, -4, one focus at 4, -4, and one vertex at 5, -4. If mx minus y is equal to 4, m is greater than 0, is a tangent to E. Find 5m square.
So like we can just say 3, -4 as 0, 0, like suppose, and then
It is center is there. So whenever
A will AE will be 1.
AE will be 1.
AE
Whenever
will be
center
2.
is displaced, your ellipse becomes something like this: x minus h whole square by a square plus y minus k whole square by b square is 1, right?
Yeah,
Center is h comma k here,
right.
right?
Yeah,
This is a standard ellipse drawn with different center. Basically, the axes are parallel to the coordinate axis. Obviously, in a more complicated question, it could have been tilted like this, right? But that is not the thing. Therefore, we can write the equation like this.
right.
AE is one we got from here because this point is center and this is focus. From vertex, one vertex is 5 comma minus 4. No? So this distance is also known, right?
2. Yeah,
So A is
2.
2. So E is half.
Ah, yeah,
So B is also known.
right. B is
So 1 by 4 is 1 minus B square by 4. So B square must be 3, right?
yeah, B is root 3.
So B is root 3, right?
Yeah.
Okay. So equation of the ellipse is now coming for us. X minus 3 whole square by 4 plus y plus 4 whole square by 3 is equal to 1, right?
Yeah.
Now what is a equation of tangent to this ellipse? Like, you know the standard equation of tangent, right?
Yeah.
So standard equation of tangent in terms of y is equal to mx plus. But here you have to realize that the standard equation will not work. You have to modify it a little bit, right?
Mm-hmm.
Because instead of y, you have y minus k, and instead of x, you have x minus h,
Yeah.
right?
Yeah.
This is your tangent,
Mm-hmm.
correct?
Yeah. Okay. Yeah. Yeah.
Now you can compare it with y is equal to mx minus 4,
What?
right?
Mm.
Here you have y is equal to mx minus 3m minus 4 minus 3m minus 4 plus minus root over 4m square plus 3, right?
Mm.
So this part should match this.
Yeah. Yeah.
Okay, so in order to match this, you will get minus 3m should be plus minus root over 4m square plus 3. So that minus 4 cancels. This should become 0, right?
Mm.
9m square should be 4m square plus 3. So 5m square should be 3, right?
Yeah.
So the key thing here is to realize that, okay, AE and A you can find, so B you can find, and then equation of the ellipse becomes this, and tangent equation, you cannot write normal stuff. It's shifted. It's this equation, right?
Yeah.
So you have to write it properly. Once you do that, then after that, it is just comparing and matching the equations. Right?
Yeah. Yeah.
Okay. One last question. This is also 2021 only. Let L be a common tangent to the curves. 4x square plus 9y square is equal to 36, and 4x square plus 4y square is equal to 31. Then the square of the slope of the line L is equal to what? One of the curves is an ellipse and the other curve is a circle.
Yeah. Yeah, maybe. You just say M is the slope of common tangent and use the standard equations for circle and ellipse.
Yeah, so you'll write one equation for the line is the same, so it should fit, it should be the common tangent to both.
Yeah.
So x square by 9 plus y square by 4 is equal to 1. Tangent would be y is equal to mx plus root over 9m square plus 4, right?
Yeah.
And x square plus y square is equal to 31 by 4. Tangent would be y is equal to mx plus
Root 31 by 4
into
yeah, the same thing, am squared. Right? So
a
1 plus,
root over 1 plus m square, no?
yeah. 1 plus m square, yeah.
Right?
Yeah,
So this part should match this part.
correct.
Then only it can be tangent. They are
Yeah.
the same line, right?
Yeah.
31 by 4 into 1 plus m square should be 9m square plus 4. So this becomes 31 plus 31m square is equal to 36m square plus 16. So 5m square is equal to 15. M square is equal to 3. Right?
Yeah.
So again, the question is just testing whether you know your tangent equations or not. So the last two were mains questions. These are like typical, like if you know your results, it is obvious.
Right.
Correct. The only mains question which was difficult was that first one,
First one. Yeah.
which you need to know that locus, otherwise you can't do it.
Right.
Okay, so ellipse is more or less done. We'll do one more class for hyperbola, and then after that we'll move to other chapters. Tomorrow will be physics though. Okay.
Yeah.
Okay, that's all for now. I'll see you tomorrow then.
Yeah.
Bye.